Hello everyone. So today I have this really interesting Diophantine equation involving this unfactorial thing. We are given that n and a both are integers. Not only integers, they are positive integers. So we have to find all the solutions, and well, you can do that by hit and try. If you just go on and put on check, you will find that n is equal to 5 is indeed a solution. But is it the only solution? Well, we are not certain about that. Maybe it is. If it is, then we have to prove that it is the only solution. That would be considered a rigorous solution for this problem, not just guessing that n is equal to 5 works. So, right first, when you see this problem, the only thing I could think of, let's try for some values. So let's put some values of n and then calculate n factorial plus 5 and then correspondingly check what does a come. So for n is equal to 1, this thing is going to be 6. That doesn't give any integral value of a. For n is equal to 2, we have this is equal to 7. Again, a is not an integer in this case. In case of 3 factorial is 6, 6 plus 5 is 11. So again, you can't find an integral value of a. For 4, 4 factorial is 24, 24 plus 5 is 29. Again, disappointment. And for 5, well, indeed, yeah, here you have 120 plus 5, that is 125, which is a perfect cube. For this, you get a is equal to 5 as well. So this is the thing we wanted right here. So let's assume now that C. I'm just sick of checking for cases like what if n is equal to 5? How long can I go and check all that? Let's just make an assumption that let n be greater than 5, because if n is less than 5, we have checked those cases and we have found just only one solution, that is n equal to 5. So let's check for ahead. Now, one thing that you might notice here is this thing, n factorial, is indeed a interesting thing. For example, when n is greater than 5, this thing is always divisible by 5. Okay, and this thing is also divisible by 9. Interesting. Why it is divisible by a 9? Well, that's because the least value of this, like it could be 6 factorial, and 6 factorial is 1 into 2 into 3 into 4 into 5 into 6, and 6 and 3 both are in multiplication, so ultimately it's divisible by 9 as well. So here we have something interesting. This step is kinda intuitive, but you'll find its reason. Let's assume n is greater than or equal to 10. Well, in that case, you see that n factorial would be divisible by 25. That's simple, because 10 factorial is like 5 into 2. That is 10, and then into 9 factorial. 9 factorial is divisible by 5, and then you have into 10. So you have the exponent of 2 as 2. Oh, sorry, exponent of 5 as 2. So 25 does divide this n factorial if n is greater than or equal to 10. And this is equal to a cube. Now the thing is, we can factor out a 5 from here, and you will have n factorial over 5 plus 1. Now a thing to notice here, that this thing right here is again divisible by 5. Like n factorial by 5, it is going to be some integer. I can divide it by 5 again. Okay, so that is it. And here, now you see that 5 divides a cube. 5 divides a cube, then it means 5 does divide a. And a is divisible by 5, then I can write a is equal to 5b. Yeah, if it is divisible by 5, I can write it as 5 times b. Just put a value here, and you will have 125 times b cubed. Well, interesting. Let's cancel out the 5 from both sides, and you will have. Now, I've said that this thing is divisible by 5, so let's write it as 5 times some integer, say m, plus 1 is equal to 25 into b cubed. Now, if you just think here, this thing is divisible by 5. Okay. And this thing is also divisible by 5. So, but here is a 1. When you divide right hand side by 5, the remainder is 0. But when you divide the left hand side by 5, the remainder is 1. How come this is possible? This is not possible. It means for n greater than or equal to 10, you're not having any solution. Well, that restricts our cases to n greater than or equal to 6 and less than or equal to 9. Well, in these cases, you have something. Uh, if you remember, I told you that these all things are all these the factorial 9, factorial 8, factorial 7, factorial 6. All these guys are divisible by 3, divisible by 9. Yeah, if they're divisible by 9, then we have a very interesting thing right here. That is that n cube is either plus 1 or minus 1 or 0 mod 9. Now, how is this true? Well, let's just see. This is kind of a notation you might not know. Might not know what is modular arithmetic. That's perfectly fine. It just means that when you divide n cubed by 9, the possible reminders are 1, minus 1, and 0 only. Let's see it through an example. Let's consider any cube of an integer. Let's say 2. 2 cubed, that is 8. That is minus 1 mod 9. But just like that, you can consider anything. So this thing is indeed true, and you can prove it because n can be 0, 1, 2, and so on till 8 mod 9. I'm not gonna write it again. Now you can both sides raise the power of 3 and you will get this result. Okay, so there's kind of a nice thing right here. So for n from 6 to 9, what we had was n factorial plus 1 is equal to a cubed. Oh, sorry, it was 5. So n factorial plus 5 is equal to a cubed. Now, as I told you, because n is greater than 5, it is from 6 to 9. So it means that n factorial is going to be divisible by 9. So if you look at the left hand side when you divide by 9, the remainder is 5. But on the right hand side, it's a cube. And we know that when we divide a cube of an integer by 9, the possible reminders are just 0, minus 1, or 1, which is nowhere equal to 5. So it means it's in contradiction. We are not getting any solution in this range. Well, another approach could be just if you just memorize these factorials, if you know, then you can just go on and plug in for 6, 7, 8, 9, and then conclude, because for n greater than or equal to 10 you have proved that this is not going to work. But this was just quite an easy way because I don't remember the factorials 8 and factorial 9. So this is how you have proved that n is equal to 6 to 9 does not work either. And if that is the case, then it means n is less than or equal to 5, and we have checked those cases manually, and we find that n is equal to 5 is the only solution here. So that was it. I hope you understood this problem and the solution. And you must share your feedback about the video. How can I improve it? And if you have any question, you might drop them in the comment section. For now, I dose off.